So in this section, we're going to have to introduce some concepts that are probably new. I know quite a bit of the things we do in the class might be a little bit of a review, but this is probably going to be new to everyone. So we're going to introduce what are called sets. And I've got examples of sets down here. So sets are a collection of objects, and they can really be anything. We're going to start with numbers, and then you'll see down in example 2, down here we're going to get to collections of letters. Sets do have, are put in these brackets, as you can see down in the things that I had highlighted. And in each set, there are what are called elements. So like in set A here, -4, 0, and 3 are elements of set A. And our sets are always labeled with capital letters. So you see that capital A is a set and capital B is a different set. Now we've got lots of different terminology up here at the top, and I'm just going to kind of introduce it as we go. So I first want to talk about this idea of a subset and not a subset. So that's going to be our first terminology we go through. So a subset means that it's part of it, and I'm just going to kind of draw a little picture here. Let's see, we have a set. A subset's going to be part of that set, so like a little piece of it. So to be a subset, everything in the first one has to be in the second one, and order is important. You can't just flip it around. And if that's not true, we put a slash through the line. So our subset symbol is kind of like a sideways U. And if it's not true, we just put a slash through and say it's not a subset. So let's look at some examples down here in example 1. So we want to know, is A subset of U? So what I'm going to do is I'm going to compare these. I want to see if everything in A is in U. So -4 is in there, 0's in there, and 3's in there. And remember I said order is important. So I want to see, is A inside U? And A is in U. All the things in A are in U. So it is, oh, that didn't write out very well. It is a subset. Let me do another one. So I'm going to look now and compare down here in part B. I'm going to compare D to A. So here's the set D. Set D just has one element. I want to know, is 0 in this other set? And yep, 0's in there. So it is a subset. Now I told you before, order is important. So we'll see it again. This time I'm going to compare A to D. I'm going to start with A. So I know, are all the elements in A also in D? So I look, -4. Is -4 in D? No, it's not. So this is not a subset. Let's see another one that's not a subset. So let's look down here at part D. I'm going to start with C, and I want to know, are all the elements of C in B? I'll look for this -4. I don't see it. -4 is not in there, so it's not a subset. All right, I've got a couple for you guys to try. I want you to try E through G. Now in number F and G, or not number, but part F and G, I didn't come up with a new name for it, so I just want to know, is the set 0, -2 a subset of E, and vice versa? So hit pause, give E, F, and G a try. All right, so starting at E, it wants to know, is set E a subset of B? So set E only has -2 in it. I come, yep, -2's in there, so it is a subset. But these other two, I gave us a new set. I want to know, is 0, -2 a subset of -2? So is 0 in the set? And that answer is no. 0 is not in that set, so it's not a subset. Then we can do the opposite way. Is -2 in this set? Yep, it is. So that means that E is a subset for that one. So E is a subset of 0, -2. I guess I can draw the arrow here. Yep, it's in there. Now H has a new symbol that we haven't gone over, so I'll do that one. And that's the empty set. The empty set has no elements in it. It is literally empty. It doesn't have anything in it. And this is kind of technical, but the empty subset the empty set is always a subset. So it's always going to be the case, not just for A. I could say the empty set's a subset of B, and the empty set's a subset of C, and the empty subset is a subset of D. It's a subset of everything, because we can always find like the empty space in there. I know that's kind of tricky. That's why I just want to go over it and let you guys know so you won't be confused later on. All right, let's look at example 2 as well. Example 2 is going to introduce this idea of a complement. That's a little prime up at the top. So the complement is basically everything that is not in A. And we're always going to compare it to, and we see up here, the universal set. The universal set is kind of like everything we're considering. It's our universe for that problem. It might change for each one. So right now our universe is the first part of the alphabet. Sometimes the universe might be a set of numbers, but the universe is kind of everything, and then we're going to pick and pull from that. So looking at the things that are not in A, so A has these letters, I guess I should, in it. So A has these letters in it. So it has A, B, C, D, and I. So what I'm left with is E, F, G, and H. That is the complement of A, the things that are not in A. So why don't you go ahead and give the B complement a try. So hit pause and see if you can come up with B complement. All right, so we're going to compare B to the universe. I want the things that are not in B. So I'm just going to kind of get rid of the things I do see. And what I'm left with is A, H, and I. So that is my answer for B complement.